Good afternoon, Algebra 2. Today we are going to be learning about solving equations with radicals. And so this is the last section in our unit, so by the time we're done today, you'll know everything you need to know in order to prepare for your test that's coming up soon. So let's go ahead and just jump right into it. Solving equations is nothing new. We're just going to have radicals involved, and I'll show you how to deal with those. So example 1 says, the time t in seconds that it takes a pendulum to complete one full swing is given by the formula t equals 2 pi times the square root of L divided by G, where L is the length of the arm of the pendulum in centimeters and G is the acceleration due to gravity. Suppose a ball on a string swinging like a pendulum takes 2 seconds to complete one swing back and forth. If G equals 980 centimeters per second squared, find the length of the string. Alright, so what I've done here is I've actually copied the important parts of this question onto the next slide so we can have some room to work here. So I've taken the equation right here, and I've taken the 2 seconds that we're going to need, and then the gravity, the acceleration due to gravity here, and I've just copied it over onto this slide. So here's what we need to do. We need to solve for L, which is what we're going to do, but we first have to plug in our 2 seconds for our time over here, and then our G we know is 980, so that's going to go right in here for the letter G. So let's go ahead and set this up and see what it looks like here. We have T, which is 2, so 2 equals 2 pi, which is built into our equation, times the square root of L, which we're still trying to find, so we leave it as L, over 980, which was our acceleration due to gravity here. So 980. All right. So our goal here is to solve for L, so we want to get L all by itself. The rule with square roots, though, is you can't undo the square root until it's the only thing on the side left to deal with here. So we have to get rid of this 2 pi first. So since it's 2 pi times all this junk, we're going to go ahead and divide by all that stuff. So we're going to divide by 2 pi. And, of course, what we do to the right, we have to do to the left. So we're going to divide by 2 pi over here. Okay. So on the right-hand side, the 2's are going to cancel and the pi's are going to cancel, leaving us with just this square root of L over 980. So square root of L over 980. And then over here, we just have 2's to cancel out. So we have this pi, but please don't just put pi here, because notice pi is in the denominator, therefore it needs to stay in the denominator. So what do we put on top? You guessed it. We're allowed to put a 1 there, and that's all. Okay, so now that we have just the square root isolated by itself, we can actually take this square root, and how do we undo square roots? We square them. And of course what we do to the left, we have to do to the right, so we're going to square this side as well. So let's do this piece by piece. 1 squared is just 1, of course, and then pi squared is pi squared. So on the left we have 1 over pi squared. Over here, we have this square root, which is going to cancel with the squared, so all I'm left with is this stuff underneath. So we have L over 980. So L over 980. Okay. We know this is L divided by 980, so to get rid of it, well, you might think, actually, we can cross multiply here, which you can, but it's just going to make more work for you. We can recognize that this L divided by 980 is just division, and to get rid of the 980, we would need to multiply by 980. So let's go ahead and do that. So we're going to multiply by 980 on either side. 980, here we go. And over here, we're going to have canceling. I'm just going to switch sides here, so L equals, and then on the right, or excuse me, on the left rather, I'm going to make this a fraction so I can multiply. Remember, we multiply fractions straight across. So 980 times 1 is just 980. And then over, well, 1 times pi squared, of course, is just pi squared. Okay? Now, this length right now means nothing to us. 980 over pi squared, I don't know what actual number that is, so let's see what that actually is as a real number. So let's grab our calculator, which means you should too. Anytime I grab my calculator, you should have yours out and handy. And we're going to do this division here. So 980 divided by, and then I would put the pi squared in parentheses. I'm not sure if it'll make a difference, but anytime I mess with squareds and division and whatnot, I always want to do the pi squared first here. So I'm going to put in parentheses to make sure that my calculator knows to do that. So we hit enter, and what do we get? 99.29. So let's write our answer. Our length here is 99.29. And then our length, remember, from the previous slide was in centimeters, so we always want to put the units on here, so centimeters for our string. All right. Next example, 2. We're going to solve 3 minus the 4th root of y equals 10. So let's go ahead and I'm just going to rewrite this so I can work with this. 3 minus the 4th root of y is equal to 10. Again, just like with square roots, if you're going to get rid of this 4th root, you have to get it isolated by itself on the side. So this 3 minus thing is a problem. Now be careful, this is not a minus 3. This 3 is actually positive if we were to put a sign there. So to get rid of this 3, we would have to subtract 3 from each side. So that's gone. And then notice this negative is still on this 4th root, so we'll have to address that in a second. So negative 4th root of y equals, well, 10 minus 3, of course, is 7. And then to get rid of this negative, we would multiply this side by negative 1, which means we have to do that on the right side too. And these negatives will cancel, and now I just have the 4th root of y equaling, well, 7 times negative 1, of course, is negative 7. Now, I need to get rid of that 4th root, I need to take this to the 4th power, because they undo each other. Just like squares and square roots, 4th roots and 4th powers undo each other. So then I'm going to do this over here to the 7 as well. So this 4th root and the 4 cancel. I'm left with just y. And then we need to take negative 7 to the 4th power. Now before we do this, knowing what we know about negative numbers and even powers, what do you guys think? Do you think this number will be positive or negative? If you said negative, you are incorrect. I'm very sorry. If you said positive, you are absolutely correct, because we know 4 of these negative 7s would cancel all those negatives out. Now your calculator, again, grab yours since I have mine. If you enter this in as such, negative 7 to the 4th power, enter. You might be like, well, Miss Warner, you just said that it was going to be a positive number. And you should know that it actually is going to be a positive number. It's just your calculator is not smart enough to realize. What your calculator does is it takes the 7 to the 4th power and then takes the opposite, which is something we've discussed in previous lessons. In order to combat this, you could either just remember that it's supposed to be positive, or you could actually put that negative 7 in parentheses and then to the 4th power, which should give us a positive number. So, and it does. So you should get 2401 as your answer. So let's go ahead and jot that down. 2401 is the answer to our problem. 2401 is the answer to our equation. All right, we have a couple more examples. I'm going to go ahead and save them for the next video. That way we can just have enough time for everything. Fabulous. See you in a moment.